I want to talk about slope today and how we're going to graph using slope. First of all, we need to know what our definition of slope is. Slope is the rise over run. You may recognize that, rise over run. A lot of times that's what we will hear when we start talking about slope. It's also the vertical change over the horizontal change. Rise means vertical, horizontal would be your run. So if I'm looking at a picture like this picture of a wheelchair ramp, if I want to find the slope, I'm going to take the rise, which would be the number that's going up, over the run, which would be this number, 17.5. So 1 over 17.5 would be the rise over run. If you're asked to simplify that without decimals, then you can move your each decimal 2 places. So 10 over 175. And you could probably leave it like that. They may want you to reduce it. You could reduce by 5s. 5 goes into 10 twice. 5 goes into 175. Let's see. 35 times. So 2 over 35 would be what it would be reduced. But a lot of times it's just going to give you whole numbers, and so you're just going to do rise over run. Now there's also a way we can figure out slope, and that's to use a slope formula. So the slope formula is m equals y2 minus y1 over x2 minus x1. Now I'm getting y2 and y1 from 2 points, x1, y1, and x2, y2. So I use this formula when I'm given 2 points. And you can find the slope. So you can find the tilt of the line. That's also another good definition for slope. So you can find the tilt of the line by taking the difference in the y's over the difference in the x's. So if I have a problem and it says find the slope of the line containing the 2 points, 3, 2, and 9, 4, I label my points first. And I just label this one because it's the first point that's listed, and the 9, 4 is the second point that's listed. So then I go to my formula. M equals, and incidentally, the letter M stands for slope. I'm not really sure why, but it stands for slope. So anytime you see M, that stands for slope, especially when we're graphing. So y2 is 4 minus y1 is 2 over x2 is 9 minus x1 is 3. And then let's just work it out. 4 minus 2 on top would be 2. 9 minus 3 on the bottom would be 6. And then that would reduce to 1 over 3. So what does that mean? Well, that means that if I'm going from the point 3, 2 to the point 9, 4, I'm rising, I'm going to use the 2 over 6. I'm rising 2 and I'm running 6. And then I get to the next point. That's going to come in handy when we start graphing using slope. Okay, let's do some more examples like this. Okay. Here we're looking at two pictures at the top, and this is giving you different kinds of slope that you can have. Slopes that run uphill from left to right are positive slopes. So if I worked out the slope for this particular line, I should get a positive number, and we'll do that in just a second. If you look over here on the right, lines that go downhill from left to right have negative slopes. So if I were to work out the one on the right, I should get a negative number. So let's try it. You may be asked to work some of these that have slopes, and you're given a picture. So find a nice point on the picture. In this case, they gave us 2 dots on the picture, so we can actually take the ordered pairs for those dots. This first one is 2, 5. And the second one looks like it's -1, -4. Now I could have taken that in the other order. I could have listed -1, -4 first, 2, 5 next, and then worked it out. You're going to get the same answer either way, but just once you write down your points, let's label them. x1, y1, x2, y2. And then let's go to our formula. y2, which is -4, minus y1, which is 5, over x2, which is -1, minus 2. So now we have negative 4 minus 5, that would be negative 9. Two negatives, add them and keep the negative. Negative 1 minus 2, add them and keep the negative, so negative 3. Negative 9 divided by negative 3 is a positive 3. And see, that is a positive slope. We end up with a positive slope. It goes uphill. This next one, I should end up with a negative slope. So let's look at these 2 points. I see a 2, 4 for 1 point, and a 4, 1 for the second point. And then let's label these x1, y1, x2, y2, and then plug it in our formula. y2 minus y1 over x2 minus x1. 1 minus 4 is negative 3. 4 minus 2 is 2. Negative 3 over 2. And it's a negative slope. It was going downhill. Now, be very careful on these. That negative that's in the formula, right here, is always in the formula. So if you have a negative for either one of the x1s or y1s, you might end up with double negatives, which is fine because double negatives end up being a positive. Just watch yourself with those signs. We'll probably have one in a minute where we've got some negatives for our x1 or y1. All right, on this one, this has a 0 slope. This line doesn't tilt at all. It's a horizontal line, doesn't tilt at all. So if I were to actually put it in the formula, I've got 1, 2 for a point, and 4, 2 for a point. So this is x1, y1, x2, y2. So 2 minus 2 over 4 minus 1. So that equals 0 over 3. And we know that we can have 0 in any fraction as long as it's on the numerator, so the number on top. And so 0 over 3 comes out to be 0. Now the next picture is a vertical line, and you'll see it says undefined slope. So what do you think is going to happen when I plug in these numbers? Think about that while I write down what these 2 ordered pairs are. 3, 2, 3, 4. If I think about undefined, I think about when I have a fraction, anytime I have 0 in the denominator, that's an undefined value because you can't divide by 0. So let's see what happens. y2, which is 4, minus y1, which is 2, over x2, which is 3, minus x1, which is 3. So I end up with 2 over 0, and that is a no-no. Can't have 0 on the bottom. That's why it's undefined. Because you ended up with a 0 in the denominator. So at the bottom of the page, if we're just looking at these 2 lines, this line goes up from left to right, so I would think it would be a positive slope. This line is a horizontal line. It has a 0 slope. Alright, so here's another picture. Again, I can give you the ordered pairs. I could give you a picture and that you would get the dots from to be able to get me 2 ordered pairs. So in this case, they're giving me ordered pairs, so I'm going to use the ones that they give me, and I'm going to label them. And so negative 4 y2 minus y1, which is 0, over x2 minus x1 is a negative 1. So here's one where I'm ending up with double negatives because my x1s and y1s, one of those was negative. So negative 4 minus 0 is just negative 4. 1 minus a minus 1, that changes. I'm going to change the color of my pen so that way when you come back and look at it, you see that I changed that to plus plus. So 1 plus 1 is 2, and then I can reduce that. Negative 4 over 2 is equal to a negative 2. That would be the slope. And that matches with what I think it should be. It's going downhill, so it should have a negative slope. Okay, we're just going to continue to work on these slopes. This time I don't have a picture, so x1, y1, x2, y2. We're just going to practice, practice, practice. Negative 7 minus a minus 4, and double negatives there. 1 minus a minus 5, double negatives again. So on this one, if I have negative 7 minus a minus 4, that would be plus a positive 4. 1 minus a minus 5 would be 1 plus 5. So on the top, negative 7 plus 4 would be negative 3. 1 plus 5 would be 6. And then I can reduce that fraction by 3s to negative 1 over 2. Okay, so I know the next example is going to be your favorite one because it's going to be working with fractions. We're going to do the same thing. You may have to worry about finding a common denominator because, again, this formula involves subtraction. So we may have to worry about that. Let's just see when we plug it in. If I've got y2, which is 5/4, minus y1, which is a negative 1/4. Okay, that'll be okay because I've got 4s on the bottom. X2 is 5 over 6 minus x1 on the bottom is 3/4. So on the top, my double negatives change to plus plus, so that's going to be 6 over 4 over 5 over 6 minus 3 over 4. Well, the common denominator for those would be 12. 6 times 2 is 12, so 5 times 2 is 10 12ths minus 4 times 3 is 12, so 3 times 3 is 9, 9 12ths. 10 12ths minus 9 12ths is equal to 1 12th. Now, this is a big division problem. So this is 6 over 4 divided by 1 over 12. So we're going to keep the 6 over 4. We're going to change to multiplication. We're going to flip the 12 to make it 12 over 1. 4 goes into itself once. 4 goes into 12 3 times. 6 times 3, 18. All that work, we get an 18 for the end. So you just kind of have to watch yourself. Take the fractions a little bit more slowly than you do the other ones so that you don't get mixed up, and you'll be just fine. Okay. Let's do one more fraction. You can see over here on the left they have another example of one. We'll do one more because I know that fractions are everyone's favorites. So here I've got 4/5, negative 4/5, minus 3/5 over 1/4 minus 1/2. So in the numerator again, they gave us the same denominator. So negative 4 over 5 minus 3 over 5 would be negative 7 over 5. Divided by, on the bottom, 4 is my denominator. So I'm going to have 1/4 minus 2 times 2 is 4, 1 times 2 is 2. 1/4 minus 2/4 is a negative 1/4. Now before I do the division, I'm just going to tell you the two negatives are going to cancel each other out. So I'm going to have 7/5 divided by 1/4. So that's 7/5 times 4 over 1. I can't do any cross canceling here, so I end up with 28 over 5 for my final answer. So that would be my slope. Alright, here's a nice one on the bottom. We're back to whole numbers again. So x1, y1, x2, y2. Now it says determine the slope of a vertical line. You know, if I'm just looking at the two ordered pairs, I may not recognize right away that it's a vertical line. But as soon as I put them in the formula, 2 minus 4 over negative 5 minus another negative 5. 2 minus 4 is negative 2 over, when I take my double negatives and make a positive, that comes to 0. So I know that that's undefined. If I had plotted these points, negative 5 up 4 and negative 5 up 2, I would have seen right away that I had a vertical line, and I know that vertical lines have a undefined slope. Okay. This one is, it says determine the slope of a horizontal line, but again, if you have decimals, you're going to use the same formula. So look what happens. I've got a 3.1 minus another 3.1, so I know that's going to cancel out and give me a 0 on top. So I know this is going to be a 0 slope before I go very far at all. negative 2.2 minus 4.2. So now I've got 0 on top. Negative 2.2 minus 4.2, that's 2 negatives, so that's going to be negative 6.4, which really doesn't matter what's on the denominator because I've got 0 on top, so I know it's going to be a 0. This would be a horizontal line, because that has 0 slope. So 4.2 is about right there. So I mean, we're looking at like right there, and then negative 2.2 right there, and this would be not a very well drawn horizontal line on my part, but it's a horizontal line nonetheless. So again, it doesn't matter what kind of order pair they give you. You're going to put it in the formula. If you want to write y first over here, let's erase that because that kind of looks messy. X2, y2. So negative 5 minus a minus 3 over 2 minus 2. You're going to end up with 0 on the bottom. So negative 5 plus 3 is going to be negative 2 over 0, which is undefined. Okay. Alright, so here's one, determine the slope of a line shown. And on this one, we are just going to have to figure out a couple of nice points because it doesn't give me any dots. So I'm looking and I see, let me get a red. Looks like we have a good point here at 0, 1. And then just look for a nice point that goes across. Looks like right here there's a good point that hits just right on target where it's easy to get the order pair. Negative 3, 3. And you just kind of have to search down the line until you can get one that's a good one. So this is x1, y1, x2, y2. So I have 3 minus 1 over negative 3 minus 0. Now I'm hoping this is going downhill. So this should be a negative slope when I work this out. 3 minus 1 is 2. Negative 3 minus 0 is negative 3, so I do end up with a negative slope, which I should because it's going downhill. So I would assume that I'm going to have a negative slope. Okay, this next one, the same thing. Let's find some good points. You can see they worked one over here and they were finding good points on it. It looks like 0, 2 is a good point, and right here. 4, negative 1. Now it looks like I could have used up here at negative 4, 5. That looks like a pretty good point too. Again, just look closely at your picture and try to pick a good point that hits right on the line so you don't have to worry about fractions. So this one is negative 1 minus 2 on top, and then 4 minus 0 on the bottom. I always try to find ones that have 0 in them because they're easier to work out. Negative 1 minus 2 is a negative 3. 4 minus 0 is 4. Negative slope, that line goes downhill, so it matches. Alright, so that is how we are going to deal with slope. The next part talks about parallel and perpendicular, but we're going to save that for another day. Have a wonderful day.